This is Unit 11, Lesson 4. So this is pretty much a continuation of the last lesson. So let's go ahead quickly, talk about the last lesson, talk about the different transformations, and see where this is going to take us. So what we learned is all these different quote-unquote transformations of a particular graph. So an example would be y is equal to -2 sine, let's make it 1/3 x minus 2, excuse me, that's different than minus 4 minus 5 or something like that. Okay, a bunch of stuff going on here. All right, so here we see the 2 itself is the amplitude. Okay, so the amplitude is equal to 2 in this situation. The -4, the x is lie, but not the y, so you would think minus would be a left, but that would be a right, because the x is lie. The outside is a y, so the x is a lie, but not the y. So this is a right 4, down 5. The front negative is a flip-flop. It's a reflection. So whatever would be up is now down. Whatever's down is now up. And then the 1/3 is an effect on the period. So the period is equal to 2 pi divided by that inside number. So in this situation, that'd be 2 pi divided by 1/3. When it's a fraction on the bottom, we come up and multiply. So this period is technically going to be 6 pi. And that's pretty much everything that you need to know. If you were to actually graph this stuff, the first thing that I do is I move everything, and then I kind of handle the rest of the business. Okay, so do all the motions first, and then you can worry about everything else. All right, so here we go. So here we have f of x is equal to negative cosine x minus 3. And they're asking for an a, h, and k. Recall that a, h, k, and then the h, just like that normal, that x motion is a liar. So it's an opposite of what you would think. All right, so I do have some missing numbers. So there's a 1, there's a +0. All right, so I see that the a in this situation is -1. The h is -0, it's 0, and then the k is a -3. A, h, and k, easy money. So here we have a g of x. You get 2 cosine x minus 1. So we do have a missing number. So I see that the a, h, k, okay, here they give us a graph already. So they said it's 2/3 sine 6x. Okay, and they want to move it up 2. So that's going to be a +2 on the outside. And the right, 11 pi over 6. So that's in with the x, and it's going to be a liar. So you would think right would be a plus, but this is going to be a minus. Okay. Again, this is where it's going right here. All right, so this is going to be 2/3 sine 6x minus 11 pi over 6 plus 2. Easy peasy. All right, so currently we have a g of x. Okay, we want to move this down 5, so that's a y motion, so it's going to be an outside minus 5, left, which is technically going to be a plus pi. Okay, we are creating a sine, amplitude, period, and a vertical shift of minus 6. Right, so the amplitude and period are exactly what they're supposed to be, but I'll just write it out just so nobody gets confused. So this is a sine graph. Okay, so the amplitude is 1, so that's good. The period is 2 pi, so that inside number is going to be 2 pi divided by that inside, divided by the period. The period in this situation is 2 pi, so 2 pi divided by 2 pi is 1. Then we have a vertical shift of negative 6, that's aka down 6. Okay, so that's going to occur on that outside minus 6. Again, you don't have to represent ones. So this is going to be sine x minus 6. So that has an amplitude of 1, a period of 2 pi, and it's moved down 6. Okay, here we have a cosine graph, amplitude, period, and again, a horizontal shift of negative 2, so that's technically left 2. So here we go. So y is equal to cosine. Okay, amplitude is 3. That's the easiest one. It's literally that outside number. Period of 6 pi. So that inside number is going to be 2 pi divided by the period. So here I see the pi's cancel out. 2 divided by 6 is 1/3. So the inside number is 1/3. Horizontal shift. Horizontal shift goes in with the x, and it's left 2. So that's technically going to be a plus 2. The x is live, but not the y. So y is equal to 3 cosine 1/3 x plus 2. Here we are creating a sine, amplitude of 5, period of pi over 8. I'm going to consider that to be 1/8 pi. We have a horizontal shift of pi over 4 and a vertical shift of negative 5. So this is technically down 5 and a horizontal shift. So this is going to be right pi over 4. Pi over 4. All right, so here we go. Sine graph. Amplitude 5. And I'll laugh at you if you get that part wrong. Period of pi over 8. So the inside number is 2 pi divided by the period, which is 1/8 pi. So I see that the pi's do cancel out, and then because this is a fraction, I come up and multiply. So this is just straight up going to be the number 16. Horizontal shift, so this is going to go right pi over 4. So right means a minus pi over 4. Minus pi over 4 in here, and then down 5 is x is live and not the y. So cleaning this up and making sure everything has proper spacing, 16x minus pi over 4 minus 5. Right pi over 4 and down 5. Yeah. Okay, let's get this equation. So this is the midline. So it starts here, it repeats itself there. So what do I notice about this thing? First and foremost, it's a sine graph because it starts in the middle, ends in the middle. Okay, it's not a cosine. And again, if you forget kind of what that looks like, this is a cosine starts in the middle, ends in the middle. So it looks like that. Okay, that's a sine. A cosine starts at the top and ends at the top. So that would be a cosine. So this one just so happens to be a sine. Okay, so this is a sine graph. I see that the amplitude, so from that midline up is 1, so that's good to go. The period is each two lines is technically 1. Each 2 lines is 1. So this is 4, so this has a period of 2. So that inside number is going to be 2 pi divided by the period, and so that's going to be 1 pi, the inside number. Okay, other weird stuff going on. This is down 3, obviously. It's down 3. And there's no flippy flop to it. It goes up and then down, so that's good to go. So that's the only other thing going on here. So here we go with the equation. All right, so this is a sine graph. So y is equal to sine. All right, so we have an amplitude of 1. Period of 2, which results in an inside number of 1 pi, and it's down 3. So that's going to be an outside minus 3. Again, you don't have to represent ones, so this is going to be sine pi x minus 3. All right, here we go. Midline is right there. It starts here, ends here. All right, so again, starts in the middle, ends in the middle. This is a sine graph. The amplitude. Each line is 1, so this has a height of 1, so amplitude of 1. The period. Each line is 1/2 pi, so this is 1/2, 2, 1/2, 2/2, 3/2, 4/2. So this is 4/2 pi, which is aka 2 pi. So if you need to go, what is the inside number? It's 2 pi divided by the period. So the inside number is 1. Okay, other weirdo stuff going on with this. I see that it's obviously up 2. So the midline is up 2. It's not moved left to right, and it goes up and not down, so it's not flippy flopped. It is what it is. All right, so let's turn this information into an equation. Okay, so this is a sine, so y is equal to sine. So we have an amplitude of 1, period of 2 pi, so that yields an inside number of 1, and then this is up 2. Again, you don't have to represent ones, so this is ultimately going to be 1 sine x plus 2. What is the equation? All right, so here's the midline. Ooh, notice it starts up and ends up. Ooh. Clever. All right, so this is going to be a cosine. Right, this is a cosine. From the midline to the top, it has a height of 1, so this has an amplitude of 1. Each line represents 2 pi side to side, so this period is going to be 2, 4, 6, 8. So the inside number is going to be 2 pi divided by the period. Pi's cancel out, that yields an inside number of 1/4. Other weirdo stuff is I see that the midline is moved up 1. It starts up, ends up, so it's not flip-flop. Okay, let's turn this into an equation, and then we'll be done. So y is equal to cosine x. All right, so this has an amplitude of 1, inside number of 1/4 for the period, and up 1, and so that's an outside. So this is going to be y is equal to cosine 1/4 x plus 1.